All right, first thing. This statement is kind of important. Metrology is a science, calibration is a process. Some of you guys work in Cal Labs, and when you do calibration, you're following set procedures. You're supposed to do them the same way every time. Well, you're going to have problems. Metrology is the science to figure out what you were doing when you do the calibrations. Both of these things are fun. I tend to say, you know, if you're doing calibrations, you're doing rote. If you're doing the metrology work, you're figuring out what the problems were. One of the big problems is the words we use are very technical. It's all technical jargon, and you have to have the same words. And it's real important, especially when you start doing audits, that when you say something, everyone knows what you mean. So they actually have definitions of metrology and calibration terms. ISO came out with one. There's an international vocabulary of metrology that they published, and it has all the definitions in it. If you work with the Navy, they don't use the same definitions for some of it. I don't know how BAE is. You probably use the ISO. The Navy uses the ANSI, which there's just enough differences to drive you crazy. It's not enough to really cause you problems, but it does drive you crazy. And then as you're going through the audits, what happens is a lot of the people will use, like me, terms that are not the same term, because that's what you've used for years, and it's hard that happens. Okay, metrology, science and measurement. Now, just a question, are you guys involved more with the raw calibrations or with the metrology?
More with just the calibration.
More with just the calibration. That's the most common thing. Most people running a Cal Lab or working in a Cal Lab, they're doing calibrations. I was fortunate. The Cal Lab I was in was not an official Navy Cal Lab because the stuff we were calibrating, for the most part, was special test equipment that went on aircraft. So, like I said, we had stuff, 55,000 items, mainly dimensional physical calibrations. A lot of it were the old, if I say steam gauges, you know what steam gauges are? Yep. They are mechanical analog gauges, you know, the dials with the point with them. And when you're doing a flight test, sometimes you lose all power. And sometimes those digital displays don't help you as you're starting to lose altitude. And you can see the gauge spinning around, and the faster it spins, the faster you're falling. Digital is just a blur, so you don't know how fast it is. And if you ever had the pleasure of going into an intentional spin in a tactical jet, you don't remember much, but you can see the numbers, the dial spinning, so that was real important. So we did calibration, but we also did the metrology, because if there's something was wrong, we had to investigate why. We also did acceptance testing of all the stuff. Any of you do acceptance testing? I know you said you did a lot of buying. You're starting to border on the metrology end when you do acceptance testing. If you do acceptance testing, anyone out there at BAE do it?
I usually cooperate with the engineers that are doing the acceptance testing, and we have test engineers that will run that through.
Okay.
They just use my equipment.
I love what you said. They use my equipment, because you're right. I'm an engineer, and I'll give you a hint. Don't let an engineer do anything alone. Okay? I'll start off with that. When we have a new engineer come in, the first thing I do with them, when I was running the division, is they spent 1 year working under a technician. And their job was to be the gopher until they could start doing stuff on their own. And it was amazing how little the engineers really know when they come out of school. And even if they've worked in the field for a while, when they come over and they're really in a hands-on field, they really don't have it. So the metrology is broken down to 3 basic subfields. The scientific one, which is what I will say the high-tech theoretical ones, you know, you're coming up with how you do the traceability, how you communicate that. The applied or industrial is the one that is more fun. You're figuring out the best way to do it and how you can do the best control of the equipment. Because, well, this is one of those classes that you tend to jump around, so I'm trying not to. But you're trying to figure out the best way to do things. And the last one is the legal ramification, and there's a lot of legal ramifications. So as you say, the engineers come in and do it. What they're doing when they're doing the acceptance testing are the legal ones. And also they're looking for the protection of the health and safety. I'll tell you a story now. Talk about the steam gauges. A lot of the gauges dates back to the 1940s and 50s. We don't make them anymore. But we had one that wasn't working right. We found a company that would repair it. So contracts and shipping people boxed up the gauge and sent it on back to the company. And we suddenly get a massive phone call. You just sent us radioactive material. You know, the green dials that would glow, that used to be radium. It was still radium. We went through and we found about 20 of the old gauges that still had the radium on them. So we had to get them shipped back a separate way, special way, and they were all, the dials were just pulled off, new dials were put on. Real simple to do. It's just we had radium on it. Yeah, so sometimes the stuff will get you 20 years later. So, okay. The definition of a calibration is a set of operations that establish under specified conditions the relationship between the values of quantities indicated by the measuring instrument or the measuring systems, or values representing the material measures, or a reference material and the corresponding value realized by standards. You think that was easy to say? Calibration is you're trying to define how the item changes with differing inputs. You want to, what I like to say is you're really not calibrating, you're modeling the item. You want to know when you change the input, what is the output change? That's a fancy way of saying that. And in order to do that, you need to know a whole bunch of things. You need to know exactly what you're putting in and exactly what you're taking out. That's another class I'm teaching later in the week. But, you know, it all comes down to understanding what's happening. And you want to do it in a repeatable method so that when the next item comes in, you know that you're getting the same results. Questions? I know this is all basic stuff. I'm going through faster than some people would like, but I think you guys don't need it. The process with metrology is applied. So we said the metrologist went ahead and came up with how to do this. The calibration technicians are making sure they're doing it right so that they're doing it. Everything I always did was traceable back to the National Bureau of Standards. I assume that's true with you guys. Some people do not have traceability to the National Bureau of Standards. They have traceability to an in-house cal lab that is not traceable to the National Bureau of Standards. If that's the case, you're going to have a problem getting certification if you go into ISO 9000. Well, they're looking for that. Now, if you're overseas, you might be traceable to the calibration system in other countries. But everything I've done has always been National Bureau of Standards. Okay. This gets real interesting now. So there's different terms for the measuring equipment. most of the stuff that I used was called test measurement and diagnostic equipment, TMDE. Sound familiar to you, Richard? No? Okay. It's not unusual. ANSI talks measuring and test equipment, M&TE. FAR talks about measurement, diagnostic, and test equipment, or special test equipment, or peculiar ground support equipment, PGSE. That's the one you use, yeah. And then ANSI, I think I said before, I don't know if I gave you definition, American National Standards Institute. They were, I jump around a bit. We'll talk about them a little later because they are very similar to ISO, but there's a difference. But having these different terms can cause confusion because special test equipment is in the FAR, and most of the stuff that I used, I owned when I ran the Cal Lab and the Special Flight Test Instrumentation Pool, special test equipment fell into that category. And there was a different set of rules in FAR for handling that. So it's anyone at BAE, do you guys have special test equipment that's on loan from the government or you buy for the government?
Yes, we do.
Yeah. And there's a whole different set of rules to handle that, isn't there?
Yeah, generally it's NIST standards and ANSI standards.
Right. You have the standards, and then you have another set of audits that they have to be audited separate and inventoried separate. That inventory is an audit. A lot of people don't realize that, but that's the politically correct term now for an inventory is you're doing an audit of the items. Metrology laboratories are different than Cal Labs because that's where you have metrology and calibration together. The main Cal Lab at Packed River was PRL, the Tuxet River Lab. The Navy is very creative in its naming of Cal Labs. And they were not one of the standards labs because it was a metrology lab. The Navy now only has the one main metrology lab officially in San Diego, but Packed River still has one because of some of the unique work being done there, and the fact that we have some stuff that's not available anywhere else because we had a lot of extra money that we could use to do things because you're testing aircraft and you're pushing the state of the art a whole lot. So metrology labs are a little different because you have both items going on there. So the metrology technicians do stuff in addition to the Cal technicians. They can do both, but they do the investigations. Alan, Dave, you fall more as metrology technicians? I know the engineers are doing the hard work, but they're doing the technical work, but you're working with them, correct?
Yes, that's correct.
Well, yeah, I used to work in metrology when I worked for AMP, and I worked there that's been like 15, 20 years ago, though.
Hasn't changed any.
No, I know.
Yeah, that's something. My father-in-law worked for a airframe manufacturer before the war and right after the war, and he'd come into our lab, and some of the same stuff would be going on in the lab as he was doing. So, 40 years later, oh yeah, now we have machines doing the data collection, but it's the same stuff.
It was about 1995 or 6, something like that.
That's when I was heavy in it, so don't feel bad. It's not that long ago. Keep telling yourself that. Okay, so when you're going through that, you're really doing a little more than just calibration. You look at the data, and even if it's within spec, you're looking at what changed, what's different. Is this what the end user really needs and wants? We'll talk about that later on with the end user. If you're a Cal Lab and a pure Cal Lab, all you do is the Cal work. And I don't mean to degrade that. There's a lot of good stuff going on, but you're doing calibrations over and over again. And if the cal interval has been set up correctly, nothing fails. Because we'll talk about that, what you do when something fails when it comes in for calibration. But you want to have that cal interval be such that everything that comes in for calibration is still within cal when you do it. Of course, it's better when it goes out many times, but it's within beforehand. So calibration technicians are the ones who do the hard work of setting everything up and making sure that the equipment is within cal that you're using, that you have the repair records, and then they write the test reports. Richard, did you write test reports when you were?
Yeah.
Yeah.
Well, wrote the test plans.
You wrote the test plan, but did you do the final reports also? Yeah. Yeah. And we'll talk about that again later in here about that, because there's a lot of tricks you can do when you're writing test results that make life very simple. It really, really can. We actually had test reports that were pull up on the computer and it just fill in the blanks and you're done. And it was very, very helpful and made it easy for the customer because it was always the same and you didn't have to worry about coming up with new ways of saying it worked or it failed. So, at the BAE, do you have corporate result formats?
Not quite sure I understand.
I'll give you an example. Boeing, they had a report format that was basically the same thing. It would come from corporate, and it would have a list of doing a voltage calibration, and it would tell you this is what you have to have in Section 1, Section 2, Section 3, the conclusions and the results. And if everything's going okay, it's real easy. If everything's not going okay, everything is still in the same format, and it makes it easy to do. At the McDonnell Douglas, I'm going back some time, but at McDonnell Douglas, every technician wrote slightly different. The formats had all the same stuff in, but it wasn't identical. And it took longer to write the reports, pure and simple.
Yeah, we have a standard report that's output for each item.
Okay.
Pretty standard.
That's pretty standard, yeah. Here's some pictures of Cal Lab technicians at work. I always love this picture of the force measurement in the calibration laboratory. Anyone ever wear a white lab coat doing that type of work?
Right now.
Yeah. Richard has a puzzled look on his face. I've seen that one time. We had in the 80s, we had a guy come in, was my boss's boss, and said, oh, we want lab coats in the Cal labs.
Out there.
He went and got white lab coats in the Cal labs, and they were of a synthetic fiber.
Okay.
And we were shocking every piece of equipment we had. They didn't last long, and they changed them from the white to a cotton. That was terrible because you couldn't keep it clean. It got a stain and be ruined. And they went over to blue lab coats, and finally they decided, we really don't need lab coats. But I find that it looks really good. He's got the symbol on it. I've looked at that picture. I don't know if you can tell. It looks like an Air Force symbol. And I'm sure it was put on for the picture and then disappeared.